Folks, here we are again with the last in the series of these stoichiometry problems that I'm sure you've been working on. And some of your problems are going to ask about the percent yield. Before you talk about or tackle the percent yield, you need to watch the first video, determining the limiting reactant. Then you should probably watch the second one too, just in case, to be able to determine moles of excess reactant. But percent yield is a really common thing that chemists do, and I want to explain a little bit about percent yield, and then we'll show you how to calculate. The calculation is really easy. It's determining how many grams of product that you're going to get that gets rather tough. So this is the equation that was given in your notes, and percent yield is the actual yield divided by the theoretical times 100. What you need to understand is the actual yield is what you get in the laboratory. So remember when we did this reaction, the amount of copper that you got would be the actual yield. And then theoretical is the yield that you would get on paper. And that's what you would do in your limiting reactant problem, the first problem in this series of videos. So you need to understand that this is what is given in the problem or what you get in the lab, and then this is what you calculate, okay? So I'm going to show you how to get the theoretical yield. Most of the time it's given in grams, and then we'll compare it to our actual. And I'm going to pretend that in the lab we got 1.38 grams of this. This is a number that has to be given in the problem. So this is going to be what we came up with in the lab. Now we need to find the theoretical, and then we can do percent yield. Pretty simple stuff, actually. Okay. So when we did this earlier in the first video, we realized that we got 0.0261 moles of copper. Okay? And we knew this because we did the whole, limiting reactant problem, and this is what we ended up with. This was the smaller number. This is the amount of copper that's going to be made. Now we need to go to grams, okay? And this is an easy grams to moles atomic mass calculation. We've done these guys 1,000 times. This is where we go to the periodic table and we realize that 1 mole of copper is 63.54 grams of copper. And then when we do the math, we realize that we get 1.66 grams of copper. If you're curious how I got this number, you need to watch the first video in the series called Determining the Limiting Reactant. This number came from the periodic table. When I do the math, I realized that on paper I should get 1.66 grams of copper. But in reality that doesn't happen. In the lab I got 1.38 grams of copper. So now that I've gone through this whole mess, and by the way, when you're doing these percent yield problems, getting this answer is more than half the work. Now this is the easy part. So now that you have the grams of product, so you could actually theoretically say, well, this plus this would give you this. But I'm telling you that this is what we got in the lab, all right? So this is how you proceed with percent yield. Basically what you do is this. You take what you got in the lab, which is 1.38 grams, divide by what you got on paper, which is 1.66 grams, multiply by 100, and in this case, in the lab today, you got roughly an 83% yield. Not terrible, not great, but certainly not terrible. And that's basically how you do a percent yield problem.